Good afternoon, dear friends. Uh, Today we will learn how to install regional spectral models with ROMs on Florida State University HPC server. To install that, there are a few steps which you can see in this document file. I will go through with each steps and will show you how it can be done. Okay. So first of all, these in the document file, second, third, and fourth has to be done. We have to download the source code. Source code can be directly downloaded from the CoApps El Nino server by exporting this CVS root variable. So first we export this variable, and you can see I'm installing in this path RCM. I have created a directory RCM ls. There is nothing inside this directory, and then I will do vi home/.basrc. In this, you just copy paste this line after after fee, and save and quit, and then source home/.basrc. Once this is done, you can use line number 4 command to download the source code cvsco install. Okay, so it has downloaded. It has created 1, 2, 3, 5 folders, and we have to make changes according to our machine to compile this code. First of all, we will need two things: netcdf library and mpitch2 library to install, and to edit machine specific path we can change sysvar.def file in def folder. So first of all, check your machine configuration, which you can check name -a. It is Linux 64-bit, and you can check which compiler you are using, MPI F90, which NC dump. So it will show you the path where your netcdf libraries as well as MPI libraries are available. So these paths are necessary, and we will export these paths in sysvar.def file. So let us do that. cd def and vi sysvar.def. So if I go line number 1, so first line number 41 need to be changed. So this is the by default path from the source code. So we will change this according to our directory. So this is first thing that need to be changed in line number 41. So this is line number 41. The machine specific path has some keywords and some variable names. So our source codes will directly call to the variable names, and those names are searched with respect to the machine keywords. So one is the institution. In our case, we have Florida State University, short name FSU. Machine is HPC, nickname is also HPC. We are using compiler as Intel. March, you can use single as well as MPI. We are using MPI. MPI version, we are using 2 and other things. So netcdf version, we are using 3. So these are the changes that need to be made. So I have already done here. So let us implement in our system file. Okay. So if I search HPC, line number 1 is this MPI. So this has to be set. Nickname is HPC, institution is FSU. So this is FPI 90. If you again search N, these are changes by default in the source code itself. Some of the changes are not available, we will include those. So line number 238 is present there and MPI F90. And if we again search line number 336, it has the path of mpitch. Okay, if we again go, so it reached to line number 1196. So there are few paths which are not available, we will add and I will show. And this has to be replaced, line number 1196, by this. So if I add this between EOF and institution, okay, so this has done. So we are using 272 processors and we will be using backfill queue to run our code. According to your machine, you can use which queue you want to use. So 272 is 256 plus 16 processors, 256 for RSM and 16 for ROMs. So this is configuration. That's all, and then we start adding these variables. Okay, so if we search here, current version of netcdf library has separated Fortran library as well as C library. So for that, these two flags need to be added in order. So wherever we find, we can add. This is the variable name, and machine specific you can define. In this, we have so many machine name. We just have to focus on either we just add in this or the variable name. Sometimes our code calls to the variables, sometimes it calls. So it is really difficult. So we add everywhere. Just like in this, our code calls to this rather than this one. So this is important variable. So sometimes the error happens. Net CDF. Okay, so we have added this. Atlas, we don't need these, so only these two changes will be sufficient. So we have these two changes we have added. Then we can go line number 608 and we can add this line. Let CDF include path as well as this line. In our HPC server, netcdf path and mpitch library are stored in lib64 directory. So some of the server use lib, so this path has to be defined according to that. And then line number 649, we can, the path is not there, so we define here HPC SROM. Also line number 657, it should be minus n, and atlas, so it will take this variable. I think all these changes have been done. This is also included. Now we can save it. So this line I'm copying to check whether all the changes I have included. So this, libnetcdff. I think everything is done. Just I have make sure that all the changes I have included so that I don't have to recompile this video again. So another step is line number 6. Vi get scar vars. In this has to include, and then we can go to makefile and then makefile ROMS. Okay, this is the older version of GCC compiler, so it has to be updated to that. Once all these 3 things are done, the next step is these to install. But let us see if this particular command works. Yes. So this path has to include install underscore dir so that the ROMS module know where to install executable file for the ROMS module. If you don't export, it will take by default any path. And this is another change that has to made, but since util folder is not available at present, we have to compile it 2 times. So I will show you. Next step will be just install and follow the steps. All are written here. So I'm just going through HPC, Intel, yes, 2, yes, netcd version 3, debug now, and 38, 33, 256 processor, 16 for RSM, and we are compiling it. So until this is done, we can, this is the same folder, so it is compiling and downloading other files like lib it has created a folder, so we can go to lib. So to the run model, we have to link some of the data to libcons folder. So for that, we can go to step 11 and link this. So SOTA files we have in vmishra fdata folder. So we have the SOTA files in netcd format. In next video, we'll show how to prepare SOTA files and initial condition data. It needs. So at present, just installation and how to run in a short way. Okay, this SOTA file is linked. Then there is one global sourcing is required if you are defining it option. Okay, and then add. Once these 2 paths are set, you can go outside libs. Okay, now you can see there are many folders. So ROMS folder is there. So you can go into the ROMS folder and then util folder to make these changes. cd utils. Although our model will stop because of that, we have to add here this library -l netcdff. Okay, So we have added this thing. Let us see if it is taking new one or whatever it is. So that part is done. So what we have done up until now is export CVS root, CVSU install. We have changed machine dependent path in sysvar.app. We have changed line number 29, scareware, scrwares, and we have changed the make file. These we have done, and then we have exported ROMS bin path so that ROMS executable can be installed in bin. Otherwise, it will directly go to the root user, and root user deny that it cannot, and model will stop. So our then to run RSM ROMS model, some of the ocean files, SSD files are required, and global forcing R2 soda files are required. This is not necessary, but if you define the option, we just have put this file into libscon. The another thing is you can also change the coupling interval and then recompile the code. This is the steps. These are the steps, like for changing the coupling interval, you need to modify ROMS nonlinear main 3d.f code, where in the coupling interval option you can change 24 to 3 for 3-hour coupling, and RSM model for rgetcon.f this to 3. But at present we are not changing it, so we are taking 24-hour coupling interval. Okay, so we will wait for our model for installation, and then I will show you how to install, how to run further. There are few things which I still can show in the meantime. Okay, so this is ROMS directory. We go back. It has created this directory. You can go here. So it has this. If I do this RSM ROMS, I hope no such file. So it may or may not have created now. So it will take some time. Anyway, it will not be a problem. Okay, so I have already installed and running this model on another folder. This RSM2. I can show you in this the output files. So output files are stored here. So it is already running and has created 4 years of data. So in 2001. J is the alias I have created to just check the running job. So I'm running this in the quaps queue, and it is running since 13 days. And these type of output files you can see. So for atmospheric files, r_pgp.files, and for ocean, these are the files. So you can check tail -f out. So these are the running steps, like model run in this way. So you can monitor your running model. Then Control C. Okay. So I can show you what are the other necessary changes. So we run our coupled model in CPL runs, and there are two important files that need to be edited. One is RSM ROMS, and I have made a copy of it. RSM ROMS under TP. This is a script that need to be edited. This is a batch script to submit the job. This has to be added in RSM ROMS. So I can add here that it need to include in the line number 9. Okay, and this is where the output will go. So for our this model, we have created a folder. This where we dump our output. RCM. So once our model will compile, it will create many other files. So one file is this, and the other file is चल रहा है, रिकॉर्ड हो रहा है. Okay. मैं अभी तुझे 5 मिनट कॉल करता हूँ. मैं रिकॉर्ड कर रहा हूँ कुछ वीडियो. So the ROMS model is compiling. It is almost finished. I think it will not even show the util folder because you already have made changes in make file. I hope it will take the latest make file rather than. Okay, so where I was. So I was saying that this file and there is another file which is necessary npi sub. Here these changes are required. So once this installation is done, I will show to make these changes and then we can go further from there. I think because we have made changes earlier in this particular file has taken as a new one rather than old. So it is advisable to change once this folder is created. Util just make changes to that. Otherwise the model should have stopped, but it has not. So it's gone further. Yeah, it is done. So it is now compiling the source code in RSM. So after ROMS is done, you can do these things. /configure in RSM runs. It is configured, and then /configure source in ROMS run. So I can write these steps. So rather than compiling all, you can go /configure configure source in RSM runs, and then once this is done, /configure source in ROMS runs, I think RSM runs, then /configure in ROMS runs, this one, and then /configure in couple run. But in couple run it should be with RSM ROMS. That's folder name. So if your model stop with an error, so you can do these 3 steps rather than going from the start, and your model is installed successfully. So if you go ROMS bin ls start.x, it has roms.x files and ocean.x files as well as runs. So now we can go further. Couple run, it has rsim script and the changes as per we need. Now we can make changes in it, make a copy of it. sorry, RSM, RSM, RSM India. Now, so following changes are needed to run the model. First, add this path. And then let us say we are running for similar case 1998 years. Let us say we are running for 2 months, days and time. ROMs TT, let us say take 400. Okay, so these path, edit accordingly. Just remove that CP, and we will be using, this is the running script below. So I'm taking these initial conditions and the surface static data. Date does not matter. So these things has to remove, kept as blank. Okay, so up to that part is done. These are the time step values. Let us keep those default. And this is for ocean boundaries. And after how many intervals you need. This information can be collected from the manual. So we are saving output of RPG files every 3-hour interval and 24, 1 day for ocean model. And this is where we need to edit output file path. So where it is? Yeah, here. Yeah. So 5 minutes. So so this is how we change output file data, and then there is one more change. If we go line number, I think we can search base sig. We can check line number 481. So after this, we can add basic. I think that's all. Basic is done, and now uh, this is done. We can check if there are okay, there is one more change. MPI sub. These lines has to be added here. Okay, so number of processor we are using 256, 255 to 256 to 271. So once these things are done, if everything is correct, so we have made these changes. Now we have to run this script. I hope everything is correct. So I again open this file. 3-hour backfill to MPI 1998 for 2 months. I can just submit it. Dispatch RSM. Let us see. Submitted the job. So it is in pending. Do I need to wait? Okay, let us wait. And output will be stored. CD RCM RCM out. So model is not running. Oh, it stopped. Maybe some yeah, it went something, but it did not find some link or file. So we can check that part. Okay, this is okay. P2SIG file. So I think the path name is incorrect. So we need to correct it. 1998. Let us see this path first. Do we have CD? Okay, no such directory. Okay, so the directory is not there. There it is. So we have to edit the path. I think fdate I have here, and R2 files I do have, but it do not have 1998. So we need to change our test year. So other things are fine. Just need to edit the, let us say 2000. Okay. And then again submit. Okay, the job is submitted. It is in pending. RCM out. So it has not created a folder. So I can remove this and has to wait. I don't know how much time it will take. Okay, so I can summarize the options. This is the total steps to run RSM ROMS model. Oh, it will run, but there is one more change and we forgot to edit that. It will run, so the code is running and linking, but there is one thing which we forgot. Oh, maybe not forgot, maybe basic. There is no need to, okay, this data path is perfectly defined. Okay, this was the path actually need to be added. Initially I made some, so this is the path which is needed. We can check up to this point. Our model is still running, so that's all. So normally it create if there is an error, it create MPI, this sort of problem. Otherwise it will keep running. So it has created so many files and now it is running further. So these are the steps our model is running. I think that's all. Thank you. This video is prepared by Amit. Thank you. Bye-bye.